Hi everyone, my name is James Chin, and today we're going to do number 59 on page 51. Two students are on a balcony 19.6 meters above the street. One student throws a ball vertically downward at 14.7 meters per second. At the same instant, another student throws a ball vertically upward at the same speed. The second ball just misses the balcony on the way down. A. What is the difference in the two balls' time in the air? B. What is the velocity of each ball as it strikes the ground? And C. How far apart are the balls 0.8 seconds after they are thrown? Let's start by drawing our diagram. I'm going to draw the balcony right here. The street is going to be down here. 19.6 meters between the balcony and the street. Here is my first student. He's going to throw the ball right off the balcony at 14.7 meters per second. My second student is going to be at the edge of the balcony. He's actually going to throw the ball up first, and then it's going to just miss the balcony and come back down. So that's going to look something like this. And it's going to be at the same speed as well, same velocity. So I'm going to make my 0 where the balls just leave the student's hand, and I'm going to make the positive direction upwards. That's positive. So in order to find the difference in the two balls' time in the air, I'm going to need to find how long the ball was in the air from here to here, and then I'm going to need to find how long the ball was in the air for the second ball. But in order to do that, I'm going to need to find the time from here to the top where it reaches its max height, and then from its max height to the bottom. So later I'm going to have to do two calculations. But first, let's do this. So let's start with ball 1. We know that the initial velocity is 14.7 meters per second. We don't know the final velocity. We know that the acceleration is negative 9.8 meters per second squared. And also, since my 0 is where the ball is on the student's hand, my displacement is actually going to be negative 19.6 meters. Actually, just made a correction up there. Since, again, this is my 0, my velocity is actually going to be negative 14.7 meters per second. So I have 3 givens. It's time to use a kinematic that will help me solve this. So I'm going to use this one. This is actually going to be a quadratic. So in order to solve for t in this quadratic, I'm going to pull out the t on the right side. So I'm going to get this. So I'm going to solve for t right using this. Negative 4.9 as well. Okay. It seems like that the first student's ball only was in the air for only 1 second. Alright, now since we know how long ball 1 was in the air from the balcony to the street, now we need to find how long ball 2 was in the air from the student's hand to its max height. So let's do that. For our givens, we know that our initial velocity is 14.7 meters per second. And since we know at the max height, the ball is going to get to the top, and then it's going to come back down. But at that instant, which at the top, it's going to be 0 meters per second. And we already know that acceleration is negative 9.8 meters per second squared. And we don't know the time, and we don't know our displacement. But with these 3, we can find out our time. In order to find out time, I'm going to use this kinematic equation. From the student's hand, 1.5 seconds. From the student's hand to the ball's max height, it's going to be 1.5 seconds. Now, in order to find the total time, we need to find the time it took for the ball from its max height to fall to the street. So, let's set that up. For my givens, I know that my initial velocity is 0 meters per second. And I know that because at the peak of the ball's path, it's gonna fall back down. So that's why it's 0 meters per second. And I already know that my acceleration is negative 9.8 meters per second. But I need one more piece of information in order to solve for time. And so I can find the displacement of this entire path here by taking 19.6 meters, which is the height from the street to the balcony, plus the height from the ball to the top here. In order to do that, I'm going to go back to my earlier set of kinematics where I didn't solve for this, but now I can. So let's do that. The displacement from the ball of the second student to the top of its path is 11.025 meters. So if I want to get the entire displacement from the ground to the top of the ball's height, I'm just going to have to add 11.025 with 19.6. Now I can solve for time. The nice thing about solving for this one is that I'm not going to end up getting a quadratic since my initial velocity is 0 meters per second. That means I can safely cancel this out and continue. I actually ended up getting a negative time here, and that's because I forgot to put my negative with the total displacement. The reason why I need to have my total displacement be negative is because now since I'm starting from here, I want to find the displacement from the top to the bottom. That means my new zero is actually going to be up here. And that's why I'm going to need to make my total displacement negative. And once I do that, I will get a positive 6.25. And once I square root that, I'm going to get 2.5 seconds. Again, the reason why I need my total displacement to be negative is because I'm moving my zero up to there. Now to find the difference of the time spent of the first ball and the second ball in the air, I'm just going to subtract 1 second from these two. And that's part A. For part B, I need to find the velocity of each ball as it strikes the ground. And in order to do that, I can go back to my set of kinematics for my first ball. And since I didn't solve for final velocity, I can just solve for final velocity, and that will be the answer to B for ball 1. Because when I find the final velocity of this, it'll be the final velocity of the ball as it strikes the ground. So I'm going to do that right now. The velocity of the first ball as it strikes the ground here is negative 24.5 meters per second. Now it's time for me to find the final velocity of the second ball. And in order to do that, I can actually go back to my previous set of kinematic equations and just fill in the blank here like I did for my first set. So I'm just going to fill it. The final velocity of the second ball is also negative 24.5 meters per second. And that's the answer to B. And for C, I need to find how far apart are the balls 0.8 seconds after they are thrown? Since I'm just finding how far the balls are apart just 0.8 seconds after they are thrown, I don't need to do any fancy kinematic equations. I can actually just point out this time as 0.8 seconds and this time as 0.8 seconds. And once I find the displacement from the ball to 0.8 seconds, I can add that from the second ball's displacement from when it traveled up 0.8 seconds. And I don't have to do any fancy kinematic equations. I can just take the speed of the ball which the student initially threw it at, which was 14.7 meters per second, and multiply it by 0.8 meters, and multiply by 0.8 seconds. And that will give you 11.6 meters. So the first ball traveled 11.76 meters within the first 0.8 seconds. And since the second student threw his ball at the same speed as the first student, I can just take this value and multiply it by 2 to get the distance of the distance between the two balls 0.8 seconds after they both threw it. The distance is 23.5 meters. And that's it.